Welcome everyone. I'm Bridget and this is Haley. We're hospital school teachers, and today we're going to learn all about neurons. We're also going to make models of neurons using pipe cleaners.
That's right, Bridget. Did you know that we have billions of neurons in our brains?
It's incredible, Haley. Neurons are special cells in our bodies that help us think, move, and feel. They're like messengers that send signals to different parts of our body.
And today, we're going to show you how neurons work by making our very own neuron out of pipe cleaners.
Are you ready to get started?
For this activity, you'll need 4 different colors of pipe cleaners and a pair of scissors. First, let's take 4 different colors of pipe cleaners. We'll need 1 for the cell body, 1 for the axon, 1 for the dendrite, and 1 for the myelin sheath.
I'm going to use blue for the cell body, green for the axon, purple for the dendrites, and white for the myelin sheath.
Me too. Now, let's shape our neuron. First, we'll take the blue pipe cleaner and bend it into a rounded shape to represent the cell body of the neuron. This is where the nucleus of the neuron is located.
Hey Haley, why was the neuron sent to the principal's office?
Because it didn't bring a pencil?
No, neurons don't need pencils.
He didn't do his homework.
Nope, it's because it had trouble controlling its impulses. Next, thread your green pipe cleaner through your blue circle and twist it into a long, straight line. This represents the axon of the neuron, which carries signals away from the cell body.
I have a joke for you, Bridget. What do you call a Tyrannosaurus under stress?
I know this one. A stressasaurus?
Great guess, but it's a nervous Rex. Here's where you need your scissors. Use the purple pipe cleaner to create multiple smaller branches extending from the cell body. That's the blue pipe cleaner. These represent the dendrites of the neuron, which receive signals from other neurons.
Haley, give me another joke.
Okay, what does a brain do when it sees its friend from across the street?
I don't know, Haley, tell me.
It gives it a brainwave.
Finally, we'll use the white pipe cleaner to represent the myelin sheath. Wrap it around the axon of the neuron, that's the green pipe cleaner, in a spiral pattern. The myelin sheath acts as insulation, helping the signals travel faster along the axon. I've got one more for you. Why didn't the brain take a bath?
Because he wasn't dirty?
No, silly. It didn't want to be brainwashed.
Look at our neurons. They're ready to send and receive signals.
So the cell body is where the nucleus is located. It's like the brain of the neuron.
That's right, and the dendrites are like little branches that receive signals from other neurons.
And the axon is like a long tail that carries signals away from the cell body to other neurons or parts of our body. With the myelin sheath, they're even more efficient. Did you know that even though we have billions of neurons, they're all connected in a special way?
That's right, Bridget. Neurons form connections with each other, creating networks that help us do everything from thinking to moving.
It's like having a giant puzzle in our brains, with each neuron playing an important role.
Well, that's all the time we have for today. We hope you had as much fun learning about neurons as we did.
Thanks for watching, and stay tuned for Dr. Ingram, one of our amazing neurologists, to provide us some medical facts about neurons. And remember, your brain is like a supercomputer with billions of neurons working together.
Wait. One more joke before we leave. Why can't a brain be 12 inches long?
Because then it would be a foot.
Okay, everyone, now that you've had a chance to learn about your neurons, let's talk some medical facts about these amazing parts of us. Neurons help us to think, move, and feel, and they do that by sending messages to each other. All of the neurons together make up the nervous system. Even the doctors who take care of neurons get their name from these awesome little things, neurologists. These tiny little cells send signals all over your body, from the top of your head all the way down to the bottom of your fingertips and tips of your toes. Even our thoughts, how we see or taste our food, are neurons at work. They can be the longest cells in your whole body, but they work together by sharing information as electricity, like tiny pieces of lightning. From the dendrites of one neuron down through the cell body, the axon here, and then the information gets shared with the next neuron's dendrites, almost like neighbors sharing gossip with each other. It's really cool and happens trillions of times a day in our bodies. It will happen millions of times in your brain during the time that we're recording this. But sometimes electricity can go in ways that it shouldn't. It goes to wrong neurons, or we can have too much electricity in our neurons. So then that electricity spreads to all the nearby neurons, and when that happens, the electricity can work in ways it shouldn't, causing what's called a seizure. So in a seizure, all of those things that neurons are in charge of, moving, thinking, even being awake, work differently than they should and in ways that aren't necessarily under our control. But the good news is we have all sorts of medications and treatments to get that pesky electricity going back in the direction it should and work to keep us from having any more seizures. And maybe you'll be able to meet one of those doctors who takes care of neurons, a neurologist.